So the title is Long-Range Transport of Contamination to the Arctic. And we want to study this long-range transport for describing the burden into the Arctic environment. Atmospheric transport is one of the major paths, and we want to describe how it's developing over time, and we want to understand the processes behind. So the strategy of what we're doing, we have long-term measurements to describe how things are developing over time, and then we are combining this with intensive field campaigns where we're trying to go in and understand the specific processes. And then we use very much of our data and in comparison with other stations. The data is going into also to development of models. And here we have the Danish O'Leary hemispheric model as the one we are focusing on. And well, that's both validation and new parameterization. The measurement activity that we have are done at Station Nord, located up here in the more northernmost of Greenland, 81-degree latitude, located on a small peninsula, and you can see it is very remote. 5 soldiers are there year-round and nobody else, and we are located 2 kilometers outside the camp. We're measuring a long series of compounds, gases, particles, meteorological parameters as well, and then we are carrying out these intensive field campaigns. We're making statistic evaluation of our data. We use receptor models, and we use the positive matrix factorization. Don't look on this one. This one is interesting because there's no constraint on it. We have free source profiles, etc. And then we use another one which is constrained, where we then have fixed source profiles, and we use those to use our measured data and then to identify from where are the sources to those. Then we have Ab-initio model, the DEM model. It's describing the whole northern hemisphere. And where we are having emission data as input data, and where we then calculate all the processes and then leading to certain levels of pollutants in the Arctic. So results, the receptor modeling, we have the 2 models here. Just look on this column here. This is the 2 models that is showing that SOx, that's sulfate, and SO2 are actually anthropogenic. But more surprising is actually showing that bromine is actually the same. And I'll come back to that. This is just a snapshot into what we can use this receptor model for further on. This is showing, for example, that the combustion source has a seasonal variation and centered with high levels during the winter time. And well, another one, going back to the bromine and seeing what can bromine. We have bromine structure here again, seasonal variation. You can see the scale over here, and you have here in ozone and elemental mercury, showing that we have some very disturbed periods every spring, and it coincides with the bromine. And actually, it's very well known that bromine is very active and are responsible for this. And we can see that here we have the bromine and sulfate that we have for 1990 and up to 2010. A very seasonal distinct pattern, and actually they're correlated. And I think this is actually the reason why we have this signal that bromine should be anthropogenic. It's not because it's coming from anthropogenic sources, but that it's actually released from the sea surface or aerosols due to the acidic aerosols coming up there. This is actually what we have from or have described earlier. This is then for the DEM model. that we have comparison of our sulfur compounds with the model and measured values, and you can see we have quite good comparison. And similarly, we have for black carbon, we have also very good comparison between the DIM model. Taking another species, the alpha HCH, you can see the comparison is not that good. The other ones shown previously have are very transport mediated, where this one is emission from the sea surface. As a last example of what we're doing out there is vertical measurements of aerosols using a cellometer. This is the cellometer located on top of our hut. Here you can see the military station. This is kind of feasibility study because that's been used in the marine boundary layer, but we can see actually some very distinct features in this. This is just time and this is the height. And what we could use those data to was to for example, see the boundary layer height. And this is the same thing you can see over here, just with in a situation where we have clouds. The last thing I will go to here is the future plans that we have. It's of course with a hut like this, we have special facility to invite other people to come out there, but we expect a 10 million funding, which is, I think is very likely that we will get them, and we will build more houses there so we can host more scientists there, and we will have another platform. This is just examples, but we will have a mobile platform that we can move from the Station Nord and out on the sea ice, and having activities there. And we can drive out there, so we will not needing aircraft but can reach it by snow scooters or other vehicles. And then we will have a third platform, which will be a vertical platform, where we will try to describe the vertical resolution. We will have unmanned air vehicles equipped with monitoring measurement equipment, and we are ground-based. This is actually the one that we expect to have there. It's DOAS that will use the scattered light from the sun. And by that I can say that we hope actually to be able to host not all of you at the same time, but I would invite you to come up there, and hopefully we will meet at Station Nord.